Okay, a little bit of twist on this exam was concept questions that are true or false. Again, circular motion was not covered in spring 2013, so that won't be on the test, but obviously we did cover friction, so that's a possibility. We'll work through these pretty quickly. An object is moving in uniform circular motion. Remember, uniform means constant speed, but it's going in a circle. So we do have a normal acceleration. So I just answered the first question. It's moving at a constant speed. Not a constant velocity, but a constant speed. Its acceleration vector always points towards the center of curvature of the path. That is true because we have no tangential acceleration. So if we draw our circle, we've got an object here. Remember, it's normal acceleration always points towards the center. There is no tangential because we're moving at a constant speed, so that one's true. Total acceleration is 0. That's false. If it's moving and it has a velocity, a sub n is v squared over r, so that component would not be 0. The velocity vector always points in the direction of motion. Well, yes, that's the definition of the velocity vector. So that's v. Okay, always pointing in the direction of motion. So I'll call that one true. It's moving at a constant angular acceleration. So angular acceleration sounds like a little bit of a tricky question here. Times r was the tangential acceleration, but we said the tangential acceleration is 0, so that's a constant angular acceleration. Be careful on words on that one. Gotta be real careful about the words because I look back at the solution and it actually answered false to this question. I believe that the correct answer is true. If it said non-zero angular acceleration, then it would indeed be false, but 0 is a constant angular acceleration. So we'll go with true. Friction force between an object and a support force. N is the normal force, W is the weight. Okay. If stationary, F is always mu sub s times n. That's false. This is true only at impending motion. If sliding, F is always opposite the direction of motion. Again, this is sort of a technicality in words. We'll go true here. Okay, it's always opposite the direction of the relative motion between the object and what it's on. If the object it was on was actually moving forward or moving as well, then that may be different, but we're not trying to be that tricky. If impending motion, F is always mu sub s times n. That is true. N is always equal to W. That is false because we could have a case where we're on a slope. We could have other forces involved, and then N would not be W. On a flat horizontal surface with no other forces, then that would be true. If sliding, F is always mu sub k times n. We'll go with true on that one. That's the definition of kinetic coefficient of friction.